So we're going to look at section 5.4, which is on, we're still looking at trig functions, but we're going to be a little bit more broad now and look at functions of any angle. So these may or may not be on the unit circle. It doesn't really matter. We're not looking at those special angles on the unit circle for a lot of these. But I just want to go through some of these examples so you see kind of the different types of questions you might be asked. First part of this says, let t be any angle in standard position. Let P of t equal x comma y, be a point on the terminal side of the angle associated with t. If r is equal to the square root of x squared plus y squared is the distance. All right, a lot of information here. Let's just sort of summarize what they're saying. We did this already a little bit. So remember that cosine is the x coordinate. Or you can think of cosine as the x coordinate. You can think of sine as the y coordinate when you're dealing with the unit circle. If you're not necessarily dealing with the unit circle, then you can think of cosine as x over r, where r is the distance from the origin out to that point on the circle. Let me give you a quick little picture. Let's say, and it may not be a unit circle, it'd be any circle, right? So the radius isn't necessarily 1. Ooh, that's a terribly drawn circle. We'll pretend. All right, let's pretend. So here's where I'm at. And let's say this is the angle. Oop, that's not very straight. Let's pretend. All right, let's pretend that's the angle. Here's t. That's the angle we're interested in. So remember, we rotate this way. The point right here, they're telling you, is x comma y. Basically, this r that they're talking about is the distance from the origin out to that point. So r is this distance right here, okay? The radius of the circle. That's why it's called r, because it's literally the radius of the circle. So when this comes up, cosine is equal to x over r. Sine is going to be equal to y over r. And tangent is going to be equal to y over x, okay? Secant, remember, is the reciprocal of cosine, so that means secant is going to be r over x, right? Just flip the cosine function. Cosecant is the reciprocal of sine, so then if I flip this, that gives me r over y. And then cotangent is the reciprocal of tangent, so cotangent is going to be x over y, the reciprocal of the tangent function. So this is not as complicated as it sounds. Really, where this r comes from, this is just Pythagorean theorem. It's the square root of x squared plus y squared. It's literally all it is. It's Pythagorean theorem. So that's what we're going to use to figure out that r value in all of these situations. This is not some big complicated formula you're going to have to remember. You're just going to use Pythagorean theorem. So the first question says, given that P is a point on the terminal side of T, what quadrant is this in, by the way? If I'm at -3, -5, that means I'm at quadrant 3, right? So if we were to make a quick sketch of this, we're talking about an angle that if we rotate it, puts us in the third quadrant somewhere. I don't know exactly where, but I know that there is a point on the terminal side of T, so T would be this entire angle, and that point is at -3, -5. That's what they're telling us. They want us to find each of the 6 trig functions. So before I get too involved, I need to figure out what r is. So r is, and by the way, here's where this comes from. It's just Pythagorean theorem. If we were to draw a perpendicular, sorry, that's so messy. If we draw a perpendicular to the nearest x-axis, r, remember, is this hypotenuse. So if you think of this side as -3 and this side as 5, -3 squared plus -5 squared gives us r squared, right? So -3 squared, of course, that'd be 9. -5 squared, of course, would be 25. Gives us r squared. 25 and 9 is 34. R is always going to be positive. R is a distance, technically, so r is always positive. So this is just going to be the square root of 34. Okay, not a pretty number, but that's okay. We can handle that. So let's go through our 6 trig functions. I'm going to start with cosine. So cosine of t is x over r from the formula up here. So x was -3 and r was the square root of 34. I'm going to leave that unrationalized for now, but that's our cosine value. Sine of t, so sine according to the rule up here is going to be y over r. And by the way, this is the same as it is more on the unit circle. The difference with the unit circle is r is 1, so we don't have to worry about it. We just say cosine is x, sine is y, and we're done with it. This works for any circle. It doesn't have to be the unit circle. So it doesn't matter what the size of the circle is. We just have to figure out what r is. So sine is going to be -5 over the square root of 34. I also want you to notice something, that because I'm in the third quadrant, remember we said the other day that in the third quadrant, your cosine and your sine value are both negative. Do you remember that? And that's what you're seeing here. And that everything should line up with everything we've said so far. Cosine is negative and sine is also negatives, and that's what we're seeing here. So just make sure your sines match up with what you'd expect based on the quadrant. All right, let's keep going. Tangent is going to be y over x. So the y value was -5. The x is -3. Clean that up a little bit. We get positive 5/3. And then let's do the other three functions. So secant is the reciprocal of cosine. So if you just take your cosine function and you flip it, or just do r over x, whichever way you want to think about it, that gives me the square root of 34 over -3, or you can put the negative out front. Cosecant is the reciprocal, remember, of sine. So same thing, we're going to flip it, or just up here, you're using r over y. That gives me radical 34 over -5. And then cotangent, of course, is the reciprocal of tangent. So you can just flip the tangent and do 3 over 5. The other way to think about it would have been to say x over y, which would have been -3 over -5, which still would have reduced to just 3/5. All right, question 2. If tangent is in the second quadrant and cosine is in, I'm sorry, let me try that again. If tangent is negative and cosine is positive, what quadrant is theta in? So they're not even looking for a value. They just want you to think about the quadrants. And this is a really important skill as we go along, figuring out what quadrant you're working in. So here's what I want you to think about. If tangent is negative, okay, where could tangent be negative? Remember, everything goes back to sine and cosine, right? Everything goes back to cosine and sine. In the first quadrant, cosine and sine are both positive, right? This is cosine, this is sine. In the second quadrant, cosine is negative, but sine is positive. In the third quadrant, cosine and sine are both negative. And in the fourth quadrant, cosine is positive and sine is negative. So we kind of use a little bit of process of elimination here based on what they're telling us. Tangent would be negative. Think about this. Tangent, remember, is sine over cosine. That was from the last lesson. The quotient identity said that tangent was equal to sine over cosine. So if tangent is negative, that means that sine and cosine have to be opposite signs. One has to be positive and one has to be negative, right? Have that thought for a second. The only way tangent can be negative is if cosine and sine are opposite signs. So that means that tangent would be negative. Your options are either quadrant 2 or quadrant 4, right? Quadrant 2 or quadrant 4, those are your options. Cosine is positive in which quadrants? Well, cosine is positive in the first, of course, and in the fourth, right? Cosine, remember, is the x-coordinate, so cosine is positive in those two quadrants. So which one do these overlap? It has to be quadrant 4 that we're talking about. So if tangent is negative, I've got to be in either 2 or 4, and if cosine is the positive term, that means that sine has to be the negative, which means I'm in the fourth quadrant. So you got to use a little bit of logic here to figure this out. Let's try another one. If sine is negative and cosine is positive. So if sine is negative in quadrants 3 and quadrant 4, right? Quadrant 3 or quadrant 4. Cosine is positive in either quadrant 1 or quadrant 4. Those are your options there, okay? So again, where does this overlap? Has to be in the fourth quadrant. These both happen to be the fourth quadrant. But sine would be negative, cosine would be positive. That has to be the fourth quadrant. That's the only one that works. Okay? All right, let's get into something called a reference angle. And I talked about this a little bit in the last lesson, but I want to kind of formalize the definition of a reference angle. So a reference angle we're going to use to solve a lot of these problems. And this definition sounds kind of formal, but we'll do a few of them, and I think you'll get the hang of it. Drawing the picture is probably the easiest way to get a reference angle every time. But what is it? It's the positive acute angle, and I'm calling this theta prime. So this is called theta prime is the notation. It looks like a little apostrophe. Theta prime. It's formed by the terminal side of theta and the nearest x-axis, okay? So that's always the angle made by the terminal side of theta and the nearest x-axis. And that reference angle is how we're going to figure out a lot of the values we need, especially when we're working with the unit circle. So how do we do this in each quadrant? So if you're in quadrant 1, the reference angle is its own angle. There's nothing really to think about. So if you're in quadrant 1, your angle, remember, in standard position looks something like this. So theta is equal to theta prime. In the first quadrant, the reference angle is its own angle. There's nothing to do. It's already acute, it's already positive, and it's made with the nearest x-axis, okay, as long as you're rotating in the counterclockwise direction. The second quadrant, let's talk about what happens in the second quadrant. So if I'm in the second quadrant, all right, let's draw an angle in quadrant 2. Okay, so here's my angle. So here's theta. First of all, where is the reference angle? So go back to the definition. It's made by the terminal side of theta and the nearest x-axis. So the terminal side of theta and the nearest x-axis would be right here, okay? So basically, it's the angle that completes the rotation to the nearest x-axis. So this little angle right in here, this wedge, is theta prime. That's our reference angle. How would we get that? So if we're working in degrees, then we would just do 180 minus the original theta. If we're working in radians, that would be pi, right? Pi minus theta. All right, so theta prime, if you're in the second quadrant, you're going to subtract it from pi or 180, whichever one you're working with. If we're in quadrant 3, let's talk about what to do in quadrant 3. So quadrant 3, let's see, let me write it in the right quadrant here. So quadrant 3, of course, is down here. So start here, we're going to rotate into the third quadrant. All right, where is the reference angle, first of all? Okay, so it's made with the terminal side and the nearest x-axis. It's not this angle here. It's got to be made with the x-axis. So theta prime would be right here, this little wedge right here. So think about, how would I get that angle? How would I get that angle? Well, would you agree that if this is 180 degrees to get me to here, this would be the entire angle minus 180. And that's what we're going to do. So we're going to take theta and we're going to subtract 180 if we're working in degrees. If we're in radians, we're going to take theta and we're going to subtract pi. And that's how we're going to get the reference angle in the third quadrant. All right, let's talk about the fourth quadrant. So if we happen to be in the fourth quadrant, so start off in the standard position, rotate all the way around right here. There we go. So there's theta, this entire angle. Okay, where is the reference angle, first of all? So it's made with the terminal side and the nearest x-axis. So this would be your theta prime right here. Okay, so it's what completes the entire 360, right? So to get theta prime in the fourth quadrant, we're going to take, if we're in degrees, we're going to do 360 minus theta. If I'm in radians, remember what 360 degrees is in radians, that's 2 pi minus theta. All right, so these are the little formulas you're going to use to get your reference angles in the other quadrants. And again, if you're in the first quadrant, theta is its own reference angle, so there's nothing to worry about. I don't think this is something I would memorize. I think I would just draw the angle every time and figure out what gets me to the nearest x-axis. I think if you get in the habit of doing that every time, these will be very easy problems for you. So let's do a couple of examples here. Find the reference angle theta prime for each of the following angles. All right, so starting with 345 degrees, let's draw a picture. So 345 degrees would put me in what quadrant? Think about that. I want to rotate 345 degrees. So this would be 90, this would be 180, this would be 270. So 345 puts me into the fourth quadrant, right? Not quite to 360, I'm in the fourth quadrant. So theta is equal to 345 degrees, this entire angle. How do I get the reference angle? Remember what it is. It's made with the terminal side and the nearest x-axis. So the reference angle has to be right here. That would be theta prime, our reference angle. So how do we get it? We want to complete the rotation to 360. So I'm going to do 360 minus the 345 that I've already traveled, and my reference angle is 15 degrees. Remember your reference angle every time. It's got to be positive and it's got to be acute. Remember, less than 90 degrees. So make sure it is every time you do it. Let's try the next one, 5 pi over 6. So 5 pi over 6 is in what quadrant? Well, it's 5/6 of a pi. So remember, this is 0, this is a half of a pi. So if we start out here, it's positive, so we're going to rotate counterclockwise. There's a half of a pi. Remember, this is a whole pi all the way to here. So I don't want to go all the way to the pi. I want to stop at 5/6 of the way. So it's going to be like right here. All right, so that's 5 pi over 6 is my original angle. The reference angle has to be made with the terminal side and the nearest x-axis, so that would be right here. That's theta prime. So theta prime, and by the way, I want you to see, I'm using the formulas I just gave you. If I'm in quadrant 2, what am I doing? I'm doing pi minus theta. So that's exactly what I'm going to do. Pi is what would complete the entire semi-rotation, I guess. So I would do pi minus the angle theta, which was 5 pi over 6. I need to get a common denominator here. So this is over 1. So this would be 6 over 6, right? So 6 pi, take away 5 pi, gives me 1 pi over 6. And so my reference angle would just be pi over 6. Let's try the next one, negative 135. So think about where that would put you. It's a negative angle. So you know you're rotating clockwise. So this would be negative 90 degrees if I stop here. I want to go 135, which would be another 45 degrees into the third quadrant. So this puts me in quadrant 3. So there's theta. All right, so since this is a negative angle, you have to be a little bit careful. That's why I like those formulas, but you don't always rely on them too much. The reference angle is going to be right here. Remember, the reference angle has to be positive. So to get the reference angle this time, think about it. I realize I'm in the third quadrant, but because it's a negative angle, this formula won't exactly apply the way I want it to. Just think about it in terms of the distance. If this was negative 135 degrees, right, to get me to this location, how would I complete the rotation to get me here? Remember, this would be 180 degrees. The whole thing would be 180. So I'm literally going to do 180 minus the 135, right? Does that make sense? That'll fill in that little gap right there and complete the rotation. So 180 minus 135 would leave me with 45 degrees. So the reference angle would be 45 degrees. The last one, theta equals 2.5, and that there's no degree symbol, so remember that would be radians, 2.5 radians. It's kind of a weird measurement, but it's 2.5 radians. Doesn't have a pi or anything in it. So think about where that would put you. This is pi over 2 radians, but in decimal form, that's about 1.57. Over here, this is pi radians, but in decimal form again, that would be about 3.14. So if I want to go 2.5, where does that put me? Well, that puts me right into that second quadrant. So here's my angle. I'm going to rotate into the second quadrant, maybe right about there. Okay. My reference angle then would be right here. This would be theta prime. So to get the reference angle, I'm just going to do pi. And I'm using pi because I'm in radian mode. Pi minus 2.5. And I'm going to get my calculator out to do that. To get a decimal, let me get a decimal approximation here. So pi, if I just assume it's about 3.14 minus 2.5 radians, gives me about 0.64. So my reference angle would be about 0.64 radians. All right, let's try another one. Given that tangent is equal to negative 2/3, and cosine is positive, they want you to use this information to find cosine theta and cosecant theta. So I actually want the values for cosine theta and cosecant theta. All right, let's draw a picture here. Okay, so I'm going to be in, well, we got to figure out the quadrant. That's the first thing we got to figure out. So what you want to think about is kind of like we were talking about earlier. Tangent is negative. So where would tangent be negative? Remember, tangent's negative where sine and cosine are opposite signs. So that means it's either quadrant 2 or quadrant 4. But cosine is positive in which of those two quadrants? Cosine, remember, is like your x. So that means you have to be in quadrant 4. So I'm going to draw an angle. Sorry, it's a little bit messy here. I'm going to draw an angle in the fourth quadrant. All right, here's my angle. Okay. What I know right now is I know that the tangent of the angle is equal to negative 2 over 3. Okay. So I know tangent is negative. I know cosine is going to be positive. So we have some point on the circle. We know that tangent is equal to negative 2 over 3. And then we know that cosine is positive. All right, so let's go back and look at the formulas that we had earlier, the little expressions we had earlier. So remember that tangent theta, let me show you what I'm talking about, from the chart we started out with. Tangent theta or tangent t, whatever you want to call it, was equal to y over x. So that's what I want you to remember. Tangent is equal to y over x. And remember, cosine was equal to x over r. So let's write that down for a second. So if tangent is equal to, lost my pen. Here we go. Tangent is equal to negative 2/3, and we know that that's equal to y over x. Now think about that. Which one would be positive and which one would be negative? Well, if I'm in the fourth quadrant, the y value has to be negative and the x value has to be positive. So what do I need to do to figure out cosine? Cosine, remember, is x over r. So I've got the x value, but I need the r value. All right, so remember what we said earlier, that x squared plus y squared, remember, was equal to r squared. So x is, we just said negative, no, I'm sorry, x was the denominator, so x was 3. And then y we said was negative 2. So that gives me 9 plus 4. So r squared equals 13, which means that r equals the square root of 13. Remember, r is always positive. So that tells us that cosine is going to be negative. I'm sorry, not negative. Cosine is going to be 3. Remember, 3 was the x value, right? The denominator. So 3 over the square root of 13. Notice this is positive, and cosine should be positive if I'm in the fourth quadrant, exactly as we said. Cosine should be positive, and there it is. Cosecant is the reciprocal of the sine function. Let's go back to the chart for a second. Or you can, so sine is y over r, which means cosecant is r over y. So let's go ahead and write that down. So cosecant is going to be r over y. Well, r we just figured out was the square root of 13. Sorry, this is a little bit messy. Let me erase some of this. I have some room to write. R we just said was the square root of 13. And then the y value back here, remember, we said was negative 2. So cosecant is going to be the square root of 13 over negative 2 for that particular angle. There's another way we could do this using triangles, and the reference angle is really what we're working with here. That's where this comes from. This little theta prime is this angle here, but let me not worry about that. Let me just stick to the formulas right now. So for now, just go back to that chart we had earlier and let's use that. Let's try the next one. Given that tangent theta is negative and cosine is also negative, they want you to find sine theta and secant theta. So let's first determine the quadrant that we're located in. All right, so if tangent is negative, that means I'm either in quadrant 2 or quadrant 4. This time cosine is negative. So which of these quadrants is cosine negative? That would be quadrant 2. So my angle that I'm going to work with is in quadrant 2. Okay, so here's the angle, like this. The point would be up here somewhere. So we're going to kind of follow the same process. So tangent of theta is equal to negative 1/3, which is y over x. So that means that x is equal to, now which one of these is positive or negative this time? I'm in the second quadrant. Would x be negative or would y be negative? Well, if I'm in the second quadrant, x would be negative. So that means my x value that I'm going to use is negative 3. My y value is going to be 1. Let's go ahead and get the r value. So x squared plus y squared, remember, equals r squared. So negative 3 squared plus 1 squared equals r squared. This gives me 9 plus 1 equals r squared, which gives me 10. So that means r is equal to the square root of 10. All right, so sine theta. So from the chart earlier, sine theta was equal to y over r. So y, we said, was 1 from back here. And r is square root of 10. I'm going to leave that unsimplified for now and just go with it. 1 over the square root of 10. Secant theta, all right, so secant is the reciprocal of cosine. Start memorizing these as you go. Cosine, remember, is x over r. So if you know cosine is x over r, that means secant has to be r over x because it's the reciprocal of cosine. All right. So secant is going to be r over x. So remember, r was the square root of 10, and x we said was -3. So secant is going to be the square root of 10 over -3. All right, let's try one more of these. Given that theta is in quadrant 4 this time. So now they're telling you you're in quadrant 4. So let's make a quick sketch. So I've got my angle. I'm going to rotate it all the way around to quadrant 4. So we're over here. Theta is this big angle right here. They tell me sine is equal to -1/3, and they want you to find the other trig functions. And we'll use the formulas, not worry about a triangle right now. We'll use the formulas we had earlier. So remember that sine theta is equal to y over r. Okay, so my y value then, which of these is negative? R cannot be negative. That means the numerator has to be negative. So that means r is equal to the 3 in the denominator, and y has to be the -1. So before we get too involved, let's find the x value. Remember, x squared plus y squared equals r squared. So x is my unknown this time. R is the -1. So we get x squared plus, well, sorry, wait a minute. I forgot to plug in r. Let's do that. We need something there. R we just said was 3. So let's put, let's put our 3. I can get my pen to cooperate. Here we go, 3. So x squared plus 1 equals 9. Subtract 1. So x squared equals 8, which means that x is equal to the square root of 8. I realize that simplifies, but I'm going to leave it square root of 8 for now. All right, let's go through all of our 6 trig ratios then. So cosine theta is equal to x over r. By the way, is cosine positive or negative if I'm in the 4th quadrant? Or the x value for that matter, is that positive or negative if I'm in the 4th quadrant? That is positive. So whether this is positive or negative depends on the quadrant. Well, because I'm in the 4th quadrant, this is positive, right? Because x is positive in the 4th quadrant. So my cosine value is going to be the square root of 8 over the r value, which we said earlier was 3, okay? So I've got the sine value, they gave that to me. Cosine is the square root of 8 over 3. Let's do tangent. Tangent theta, remember, is y over x. So my y value was -1, and my x value was the square root of 8. So tangent is -1 over the square root of 8. I'm going to clear this out a little bit so I have some room to write. Okay. All right, so we've got our x value, we've got y, and we've got r. Let's do the reciprocal functions. So I'm going to try not to look back at the chart. Let's just do cosine. The reciprocal of cosine, remember, is secant. So if you remember that cosine, the reciprocal of cosine is secant, and you have the cosine value, all you have to do to get secant is flip it. So if cosine is the square root of 8 over 3, secant is going to be 3 over the square root of 8. Let's do the reciprocal of sine, which is cosecant. So a sine was given to me, it was -1/3. So when I flip it, cosecant would be -3 over 1, or just -3. And then last but not least, cotangent is the reciprocal of tangent. So if cotangent, or if tangent is -1 over the square root of 8, cotangent is going to be negative square root of 8 over 1. So those are my other 5 trig ratios. Here's sine they gave us. Here's the cosine value. Here's the tangent value. Here's secant. Here's cosecant, and then here's cotangent. If you know sine and cosine and then you figure out tangent, the other 3 are easy because you just take the reciprocals of each one, and that's all you're going to have to do, okay?